Hello, dear students, welcome back to Success Edutech. We shall continue with the series of Science and Technology, chapter number 3 Current Electricity, lecture number 2. We are going to continue with the concept of current, resistance, and Ohm's law. These are the very important concepts which we should understand clearly in order to deal with the chapter Current Electricity. In the previous lecture, we studied about free electrons. Do you remember? Free electrons we studied about. The free electrons are the electrons which are present in a metal. Electrons are negatively charged. In an atom, there are total 3 charges that we discussed in the previous lecture. The electron, which is negatively charged, the proton, which is positively charged, and neutron, which are neutral. As their name, they are neutral, they are not having any charge. And it is the electron which is negatively charged responsible for carrying current through a conductor. I am using the word conductor because conductor are the ones who allows the current to flow through it. So free electrons are present inside the metals like gold, silver, copper, aluminium. These are all the metals. In the metals there are free electrons. In the non-metal there are no free electrons. Like wood, rubber, plastic, they won't allow the electrons, free electrons, and they won't allow the current to pass through it because they do not consist of free electrons in them. So it is the conductor, it is a metal which are called as the good conductors because they are allowing the current to pass through it and they are having free electrons in them. Okay, can you see here? This is a metal wire. Okay, this is a metal wire. Metal wire means it will be a conductor which will allow the current to flow through it. And there are electrons in this. There are electrons in it. Can you see the electrons? These are all the electrons in it. And these electrons are free electrons. The conductor over here is not connected to any wire. There is simple metal wire which is not connected to any other wire, any other potential difference. Potential difference we studied in the previous lecture. It is the difference in the potential. Like here it is a positive potential, here is negative potential. In the figure B, there is a motion of electrons when potential difference is applied. The difference between figure 1 and figure 2 is the differences. Here the potential difference is applied, here there is no potential difference applied. So as soon as the potential difference is applied, the electrons which were in the random position over here have aligned in one direction, isn't it? They have aligned in one direction. And as we know that electrons flow from lower potential to higher potential. They flow in this manner. So the reason the electrons which were random here, which were not having any position, these electrons are the free ones. These electrons are the free ones, free electrons. They got aligned in this direction because the flow of electron is from lower potential to higher potential. Whereas you remember the charges flow from higher potential to lower potential like water, like a waterfall. And electrons flow from lower potential to higher potential. So in the figure A, the wire was not connected to any potential difference, not connected to a cell. In the figure B, the wire is connected, the conductor is connected to a potential difference, and hence the electrons start flowing. This flow of electron is called as a current. Okay, so we proceed towards the definition of an electric current. An electric current is the flow of electrons through a conductor. We saw this was a conductor we used. Once the potential difference is applied, all the electrons got aligned in one direction from negative potential to positive potential, and this flow of electron is called as a current. Quantitatively, current is defined as a charge passing through a conductor in a unit time. The electrons are passing, correct, through a conductor. So electrons are having some charge. What is the charge? Negative charge. So current is defined as a charge, means electrons passing through a conductor in unit time. Using this definition, we can derive the formula for current as. See what the definition say. Current is the charge. Charge is denoted by Q letter. through a conductor in unit time. Okay, so I is equal to q by t. Okay, I is equal to q by t. This is taken from the definition itself. So either you remember this expression or you remember the definition. Either of them, if you remember, you are able to derive it. So if the charge is flowing through cross section of a conductor in time t, then current I is equal to q by t. Okay, and unit of the current, which is I is equal to q by t. See, the unit of the q, that is charge, is coulomb. Unit of charge is coulomb. Okay, and unit of time is second. So you can say 1 ampere is equal to 1 coulomb per 1 second. Okay, in other words, the unit of current is ampere, just ampere. Okay, it is just ampere. It is name in the honor of a scientist, Ampere. Who is he? We will see in the next slide. Okay, we say that according to definition, current is defined as a charge passing through a conductor. So actually it is what? A flow of electron, and this charge is what? Electron. So that means electron is having some charge. So that charge of one electron is 1.6 into 10 raised to minus 19. It is 1.6 into 10 raised to minus 19, and it is a negative charge on the electron. That you need to remember. So this 1 ampere current is set to, this 1 ampere current is set to flow in a conductor if 1 coulomb of charge flows through it in every 1 second. Okay, this formula of 1 ampere is from the definition itself. See here, you can see a scientist, Ampere. Okay, he was the first mathematician and scientist, conducted a number of experiments on electricity, and today we can measure the current flowing in the conductor only because of his work. And the unit of current is called ampere in recognition of his great work. His name was Ampere. Also remember 1 milli we saw in the previous potential difference. At the time also we saw what is milli. Milli is 10 raised to minus 3 and micro is 10 raised to minus 6, and it is amperes. Okay, this representation of a very small current. When current is expressed in milliamperes, 10 raised to minus 3 ampere. 1 microampere, 10 raised to minus 6 ampere. Now a small example based on the formula Q, I is equal to Q by T. A current of 0.4 ampere flows through a conductor for 5 minutes. Okay, there is a current of 4 ampere, so you should write in the given quantity current flowing for 5 minutes in the conductor. Okay, 5 minutes, that we have to convert it into seconds always, because we are into SI unit, and in SI the unit for time is in seconds. So T is equal to 5 minutes. Minutes converted into seconds, 5 into 60, 300 seconds. And they have asked how much charge would have passed through it. So we know that I is equal to Q by T. Fine. And when they have asked us to find out the charge, at the time we just rearrange. We put at charge is equal to I into T. Charge is equal to I into T. Current is given to you, time is given to you. Simply substitute the value and get the answer. Multiply and let me know what answer you get. Okay, just mention your answers in the comment section. Verify your answers that it will come out to be 120 coulomb. Now this is a question which is similar to the above question. I request you to read it, and you can solve that question by this formula itself. Okay, the same formula you have to use. So just try yourself and mention the answer in your comment section. Here also I have provided with the answer. Verify your answer with that. Any doubt, please mention in the comment section. Now coming on towards Ohm's law. Again, Ohm is the name of a scientist. Okay, he was a scientist and he gave information about resistance. Let us move on. The Ohm's law, he gave a very important law in current electricity. What he said, the relationship between the current flowing through a wire I and the potential difference across its ends V can be obtained. The relationship between the current and the potential difference can be obtained from the law that was given by German scientist George Simon Ohm. Okay, what he said, what law he gave, if the physical state of a conductor remains constant, okay, when there is a conductor with you, and if its length, area of cross section, and its whatever the material is used, all are the physical states of the conductor. When it remains constant, the current I flowing through it is directly proportional to the potential difference between its two ends. So this is the relationship between current and potential difference was given by Ohm. What is said? The current is directly proportional to V. This sign is directly proportional sign. I stands for current, V stands for voltage. When we remove the directly proportionality sign, we have to give some proportionality, constant of proportionality. Okay, so I is equal to kV, where k is the constant of proportionality. When you take k on this side, so I into 1 by k is equal to V. You can take this 1 by k as another value R, which is the resistance of a conductor, and IR is equal to V. Okay, or you can also write it as V is equal to IR, or you can write it as R is equal to V by I. This entire thing is known as Ohm's law. Ohm's law, what did he do? You should remember that he gave the relationship between the current flowing through a conductor and the potential difference across it. And you should remember the expression V is equals to IR. The unit of the resistance is called Ohm. It is indicated by the symbol. This is a Greek symbol. Fine. And now did you understand what is resistance? It is just a conductor is present. There is a conductor. Okay, you remember in the, do you know in the river, the water flow in this manner. Okay, it does not flow straight. Why? Because there is some obstacles in between, correct? Similarly, when this is a conductor, a wire, a metal wire, current is flowing through it, but the wire itself has some resistance in it, some obstacles present in it. So the current does not move in a straight line through the conductor. It moves with some jerks, okay, some obstacles. So this is called as a resistance. Fine. So generally we represent resistance as this is a wire and some obstacle. So this is the resistance R. The resistance is a quantity which slows down or opposes the flow of current. Every material has some impurity in it, because of which there is a resistance to the flow of current. That is called as resistance. So resistance of 1 ohm is what? If 1 ampere current flows through a conductor, when 1 volt potential difference is applied between its ends, then the resistance of the conductor is 1 ohm. So 1 volt of 1 volt of potential difference, 1 ampere current, at the time you will get 1 ohm resistance. So there are some example based on the Ohm's law. These are very simple example based on the relation V is equal to IR. That's it, you should remember. Read it, write the given quantity. The resistance of a filament of a light bulb in 1000 ohm. Okay. If now you write the given quantity as 1000 ohm is given. If the bulb is fed by a current from a source of potential difference 230 volt, potential difference is given to you. How much current will flow through it? So we need I. Okay, to find out I. You have V, you have R. Just write down, rearrange this. Take it as I is equal to V by R. Okay, substitute the value. Everything is in SI unit, no problem. Substitute the value, calculate it comes out to be 0.23 ampere. So current flowing through the filament of the bulb is 0.23 ampere. Now moving on towards next example. A current of 0.24 ampere flows through a conductor when a potential difference of 24 volt is applied between its end. What is the resistance? So they have given the current value, note it down. They have given the voltage value, note it down. The potential difference itself is a volt. You have the formula of Ohm, that is V is equal to IR. Rearrange it to find out R. So R will be equal to V by I. So V is given 24 volt. I is given 0.24 volt. And you have to find out R. Here they have done a small mistake. Here it should be R. And when you solve this, you will get R as 100 ohm. Try to solve it on your own. If there is any problem in the solution, just let me know. I will solve it for you. Now coming on towards another example of Ohm's law. Determine the current that will flow when a potential difference of 33 volt, they have given the potential difference, is applied between two ends of an appliance having resistance of 110 ohm. So they have given the potential difference, they have given the resistance. They are asking us to determine the current. Hold on till this point. You have to find out the current. You know the relationship between voltage and current, that V is equals to IR. Fine. They have asked us to find out the current in the first up till here. Okay, so I is equal to V by R. So you have this relation, I is equal to V by R. Voltage is 33 volts and resistance is 110 volts. You will get the current as 0.3 ampere. Okay, till now it is clear. The next they have asked is, If the same current is to flow through an appliance, means current of 0.3 ampere is to flow through an appliance having the resistance of 500 ohm. So now what all things you have? You have the current ka value, okay? You have resistance ka value, which is 500 ohm. Note it down. How much potential difference should be applied across it? Now you have to find out V when your current is 0.3 ampere, okay, and your resistance is 500 ampere. Use the same relation, V is equal to IR. Put the value of I as 0.3 ampere and resistance as 500 ohm, okay, and just calculate it. It comes out to be 150 volt. So the required potential difference between its two ends is 150 volt. Solve it taking a pen and a paper, multiply it properly, do the calculations properly, use only this formula, V is equal to IR. All the three problems will be solved easily. So in short, what we have studied today, we have studied that the current is represented by I and its unit is ampere. The current is defined as a charge flowing through a conductor in a unit time. So charge flowing through the conductor in a unit time, it comes out to be I is equal to Q by T. Charge of one electron is 1.6 into 10 raised to minus 19. And most important, which is Ohm's law. Ohm's law is, it gives relationship between the voltage and the current, and that relationship is V is equals to IR. Okay, that is it we have learned today, and in the coming lectures we are going to learn more about resistance, electrical components, and we are going to solve very interesting numericals based on those. Thank you for watching. Don't forget to like, share and subscribe. Do solve the try yourself questions on your own. Thank you so much.